All right, welcome. This is Secondary Math 2, Unit 1.3, Basic Exponent Properties. So, last time we used a little bit of exponents when we did our polynomials, adding and subtracting and all of that. But today we're going to focus on exponents and their properties, okay? An exponent is a quantity that shows the number of times a given number is being multiplied by itself. All right, so if we do x to the fifth, I mean that's the same thing as multiplying x by itself 5 times. Okay, same thing if we have something like x plus 1 squared, that is the same thing as x plus 1 times x plus 1. Okay, and I've had people make mistakes to think, oh, well, I can just distribute that and do x squared plus 1. Okay, that would be incorrect. We need to make sure we FOIL and would end up getting x squared plus 2x plus 1. All right, so just remember that. We'll talk a little bit more about that as things go on. Okay, so for an example here would be 2 times 2 times 2. Well, that is the same thing as 2 to the third, okay, or that would be 8. All right, over here we have an exponential term contains a base and a power, also known as the exponent. So here for this example, a would be the base and n would be the power or the exponent. All right, notice that to simplify the exponents, the two expressions must have the same base. All right, so if you multiplied x times x, well, that is x squared. But if we did x times y, we can't simplify that. We can't combine them. We can't simplify. It would stay the same. Okay, so it's only the ones that have the same base. Okay, if you have coefficients in front of your exponent base pairs, so for example, if we have a 2 in front of this x and we have a 3 in front of a x squared, what you would get is you would multiply those numbers together. Okay, when you multiply, we're basically multiplying all of these terms, and with multiplication, the order doesn't matter. So we can multiply the 2 and 3 to give us 6, and then we can multiply that x by x squared to give us x cubed. All right, so let's go over some of these properties. The product of powers. So product is the same thing as multiplication. Okay, so let's do it kind of generic. Let's say if we have some variable x with an exponent of with some sort of number, we're going to call it n. It could be 5 or 6 or 8 or a million. Okay, and then we're going to multiply it by another x and a different exponent. Okay, and they could be the same. It doesn't matter. All right, but when you multiply, if they have the same base, what we do is we add the exponents. Okay, and you can kind of look at an example here. If we had like x squared times x to the third, well, x squared would be x times x, and then x to the third would be x times x, which would give us x to the fifth. Okay, which is, I guess, this example right here. So that would be x to the fifth. Next one. So here, this is a mistake that sometimes people have, is when we have these bases, they will stay the same. We don't multiply them or anything. We keep the same base, and then we add their exponents. So that would be 4 plus 8, which would be 2 to the 12th. All right? Again, it's kind of the same thing. This would be, 2 times 2 times 2 times 2, and then we'd do 8 more, blah, 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 blah. Again, you'd be multiplying 12 twos. That's why we get 2 to the 12. All right, next we have, remember one of the rules is that we have to have the same base, so we could only evaluate these two to simplify. So v to the third times v to the fifth, remember we add their exponents, so we'd have v to the 8, and then we'd still have y to the 7th. Okay, quotient of powers. So quotient is the same thing as division. Okay, so let's kind of come up with the same sort of thing. Let's do some base, we'll call it x, to some exponent n, and instead of multiplying as we did last time, we're going to divide. So x to the n. All right, so whenever we divide two base pairs, we subtract them, so n minus m. Okay, and I'll kind of give you an example of that. So for this one right here, this would be the same thing as x times x times x times x times x over x times x, and then they cancel. Okay, so we end up getting x to the third. Okay, which is the same thing as x to the 5 minus 2. Right? So I would suggest probably not doing it this way, but if you forget, you could always give that a shot. Okay? Sometimes the exponents get kind of big, but if you can't remember that the quotient of powers, you subtract their exponents, then that would be a try. Okay? So here's another one. Keep the same base, be 5. Okay, don't be thinking, oh, well, I can cancel those 5s. Can't do that. Okay, so we keep the same base, but we're going to do 14 minus 9. And that gives us 5 to the 5th. Okay? All right, zeros. Anything, any number or any variable to the 0 power is always 1, no matter what. Okay? So, for example, y to the 0, well, that's 1. What about this one? We put it in a parenthesis, 2w to the 0, it's also 1. Okay, now this one's kind of tricky, so pay attention to this one. See if you can do it by yourself. Think about that for a minute. Okay, so this exponent of 2 only goes to what's touching. Okay, so since only the r has the exponent of 2, we would have 5 still multiplied by 1, because r to the 0 is 1, which would give us 5. Right? So the difference between the one above is we have that parenthesis, and this 0 is going to, this is like the same thing as 2 to the 0 and w to the 0. Okay, you kind of distribute those exponents, right? But again, yeah, all right. We'll talk more about distributing exponents in a little bit. Okay, negative exponents. Let's say we have x to the negative n, all right? The trick here is that that's the same thing as 1 over x to the n, all right? So what you do is you bring it to the top and change its sign. Okay? If we have, this would be like another example, if we had 1 over x to the negative n, we would do the same thing. But this time, since it's on the bottom, we would bring it to the top and change the sign. Okay, so for example, t to the negative 7, well, that's just the same as 1 over t to the 7. Sorry, I didn't say negative. T to the negative 7 is the same as 1 over t to the positive 7. Okay, now look at this next one. See if you can do that. Pause if you can. This one may be a little tricky. All right. Okay, so again, just kind of like we talked about before in this example, this negative 1 only applies to what's touching. Okay, So we'd want to bring that to the top and change its sign, but the 5 will stay in the denominator, okay? If this example had something like 5r to the negative 1, if that was the example, then we'd bring the whole thing up, okay? So mind those parentheses. Power of a power. So if we have some variable to a power, and then it's to another power, let's call it m, okay? That is the same thing as x to the n times, well, I guess I should do it like a dot, times m, okay? So for example, let's kind of zoom into here. Sorry, it's being a little glitchy today. Okay, so here what we'd do is we would multiply those exponents. So we get x to the 6th. Okay, next one, remember that this 2 applies to everything inside that parenthesis. So we'd have, I think my pencil's dying. Hang on. I'll give this a shot. Where are we? This is the homework. It's just switching all over the place. Is it still working? Sorry about that. Okay, so the 2 would go to the 2 as well as the x to the 4th. Okay, so this would be like the same thing. And then we would end up getting 4x to the 8 because we multiply these numbers. Okay, the next one, so like we said before, if we have numbers in front of our bases, we can multiply that. So that could be the same as 6x times y all to the 4th. And then remember that this exponent of 4 goes to all of those. So 6 to the 4th, x to the 4th, and y to the 4th. Okay? And then you could plug 6 to the 4th to figure out what that is. Let me put that in real quick. So that would be 6 times 6 times 6 times 6. And that would give us 1,296. 1,296 x to the 4th, y to the 4th. Okay? All right. So let's kind of talk about this again. I mentioned it before. But we cannot, whenever we have something in a parenthesis and we're adding or subtracting inside, we cannot distribute that way. Okay? Because remember, this would be the same as x plus 2, times x plus 2. Okay? Sorry, that didn't look like it very well. This is not working very well today. So 2 times x plus 2, and then you'd need to FOIL. And you'd end up getting x squared plus 4x plus 4. Okay? After you combine like terms, that's what you would get. All right? If you distributed, all you would get, which would be incorrect, you'd get x squared plus 4, which would be wrong. Okay? All right, so here's some examples. I may have to pause and combine these two so my pen can charge, but we'll see what we can do. I'm going to try and go over all of these. In class, I only went over like, I think 6 of them. So I'll do them really quick so that you can have examples. So this one, we multiply the numbers in front of the bases, which would give us 4. Would have sorry. It's doing something weird with my hand whenever I touch my hand on there. Okay, so we'd get n times n, and n times n is the same as n squared. Okay, next one we have a power inside of a power, so we multiply, we get r r to the 6th. Okay, this one, remember, everything is to the fourth, or to the squared. So this would be the same as 5 squared x squared, or 25x squared. Okay, next one, we have the same base, so we'll add their exponents. Okay, whenever you don't have a number for your exponent, it will always be 1. So n to the 1 is the same as n. So we have 2, and then we'll do n to the 1 plus 4, which is the same as 2n to the 5th. Okay? Sorry, I'm trying to be very careful so I don't mess this all up with this Apple pen or pencil or whatever. Okay, here, multiply the numbers in front, that gives us 6. And then we have the same bases, so we add their exponents. So x to the 5th. Okay, next, here we have 2 bases that are the same, so we can add them together. So 3k to the negative 3 plus 2, that's the same thing as 3x to the negative 1. And remember, the rule is that you should only, it's right here, you should only have positive exponents. So if we have a negative exponent, remember the thing we can do is we can bring it to the bottom and change its sign. So we'd still have 3 at the top, and then we'd bring k to the bottom and make it be a positive 1. And k to the 1 is just k. Okay, here's another example. Multiply the numbers in front, that gives us 6. And then we'll do n to the negative 3. And then this one, our exponent would be 1, so we'll add 1 to it. That would give us 6n to the negative 2. And since it's a negative exponent, we'll bring it to the bottom. So we'll have 6 over n and then change the sign. Okay, next one, we have a power inside of a power. Okay, we can rewrite this as 2 to the 3rd and then have b to the 4th to the 3rd. Okay, same thing, basically we're distributing that. We can do that because we're not adding or subtracting anything inside, and that would give us 8b to the 12th. Okay, because we multiply the exponents when we have a power inside of a power. Okay, this one, remember anything underneath an exponent that is 0 is just 1. Okay, if you wanted to distribute, you get 5 to the 0, t to the 0. Either way, it's going to be 1 times 1, which is just 1. All right, j. Again, we have a power inside of a power. Okay, we can rewrite this as 2 to the negative 3 times p to the negative 2 to the negative 3. All right. We do the same thing. If we have a number to the negative 3, we can bring that to the bottom. Okay, and then here we multiply. So negative 2 times a negative 3 will give us a positive 6. So we'll end up having p to the positive 6 over 2 to the 3rd. So we bring it down, we change the sign of the exponent. Okay, and then we could simplify. 2 to the 3rd is 8. So that gives us the same thing as p to the 6th over 8. All right, next. Again, we have a power inside of a power. So it would be the same thing as 3 to the 3rd. And then r to the negative 1, all to the 3rd. And then we will just evaluate those exponents. We'll get 9 r to the negative 3rd, or negative 3. Okay, and then again we have a negative, so we need to bring it to the bottom so we don't have a negative exponent. So that would bring us to a 9 over r to the positive 3. Okay, here we have a quotient of powers. So when we have a quotient like that, we will subtract the exponents. So that'd be the same thing as x to the 5 minus 2, or x to the 3rd. Okay? M, We have a lot of these. Okay, on the top we have a power inside of a power, so maybe we'll evaluate that first. That would give us x to the positive 4 over 3 times x. Okay, and then we have a quotient, so that would be the same thing as x to the 4th minus 1, because this is the same as an exponent of 1 over 3, which is x to the 3rd over 3. Okay? You could also think was like canceling one of our x's off, and that would leave us with a 3. Either way. All right, n. Okay, so we have two numbers in here. These are all being multiplied, so we can take care of that. And then we can add ones that have the same base. So since these two, we'll do a double line underneath, those have the same base, and we're multiplying them, so we'll add their exponents. So that'd be n to the 3 plus 4 times m to the 4. So we just get 8n to the 7th, m to the 4th. O, okay, so you don't necessarily, with many of these problems, you can do them differently. So for example, you could bring this to the bottom and change its sign first, okay? Or we could realize that we're also multiplying the same base, so we can add their exponents. So here we could do it that way. So let's first multiply the numbers. That would give us 8. Then let's look at these x's. Since they're multiplied, we'll do x to the 1 plus 3, and then we'll do y to the 2 plus a negative 3. Okay, so think about that for a second. Make sure you're getting that. Then that will give us 8x to the 4th, y to the negative 1, and then here you would bring it down to the bottom. So it just depends on when you want to bring it down. 8x to the 4th over y. Like if you did bring it down, here's an example. If we went 8 and then we did our x 1 plus 3, and then if we had this y squared and then we decided to bring the other y down and made that positive, then either way you would need to, the quotient you would subtract and you'd still have a y to the negative 1. So I mean, there's lots of things. I mean, as long as you follow those rules, you'll end up having the same answer. Okay? All right. P. Okay, so you can look at these and you could, we can do a lot of these things differently. Like here we could cancel a 2 here. Sorry, it's just being really finicky. So we could cancel a 2 on both sides. That would leave us with a 3. And then we could multiply those 3's together, and that would give us a 9. And there's lots of different ways to do this. Okay? And then we could even bring something up. Even though it's positive, we could do y to the 4th times y squared, and then we could bring it to the top and do y to the negative 3. And since they're all multiplied, we can add their exponents. So y to the 4 plus 2 minus 3, that would give us 9y to the 3. Okay? So, I mean, we can do anything. So I guess I didn't really mention that before, is you could do the opposite. You could make it be negative. Okay? The last two, I'm just going to leave those there if you want to look at it. I did that in class. You could follow, maybe I'll just walk you through it, okay? So here, this is a negative, so you can bring it down to the bottom, make it be positive. Since they have the same base, we'll add them together. That would give us x to the 6th. And then we can simplify the 6/2 to get 3. And that gives us our negative 3 over x to the 6th. And then this one, what we did is we have this negative exponent of 1. So, and the whole thing is over this, what's in the parenthesis. So we can bring it to the top and change its sign. Okay, and that's what we get right here. And then we can, since we have all these same bases that are x, we'll add all of those exponents, the 3, the 2, and the 2, and that will give us the 7. And then we'll multiply these 2's to give us 4. All right, so hopefully that helped a little bit. Again, in class, I only went over 6 of those, so there's all of those. So hopefully, if you felt like you were comfortable with how to do this, you didn't watch all of these. And again, I should have said this before, pause and do a few examples before you try or watch it so that you can practice. Okay? All right, we'll see you later.